Justin, wait. Who got cousins?
What? You got cousin? I was pretty.
You're looking at them?
Yeah.
Yeah.
Being that was on us.
Mm-hmm.
Exactly. We were hyping up to this for a year. Yeah. Whatever. Yeah. Don't be surprised when those tennis courts are burned down today.
All right. You can't see this. We're going to learn how to find what are called exact trig values. I'm going to say to you something like, find the sine of 225, and you need to know how to find that without your calculator. You have to find the exact version of it, not like the decimal version of it in your calculator. That's what exact trig values are. There are two ways to do it. Today's the first way. Tomorrow will be the second way. So that's why tomorrow's way is actually easier, but you have to do something extra for it. But before we begin, though, I need to review with you how to, or good old-fashioned right triangles, where this is 30 and this is 60. If you can recall with me, opposite the 30 degrees, you would have what's called the short leg. If I call the short leg 1, the hypotenuse is always double the short leg. So the hypotenuse would be 2. And then opposite the 60 degree would be this short leg times root 3. So we're just going to write it as root 3. Does that look familiar to you? It's actually on SATs at the beginning in the formulas section. And then there's another right triangle called the 45, 45, 90. And again, if the legs are 1 and 1, then the hypotenuse would be root 2. Okay, so if I were to say to you now, find the sine of 30, the cosine of 60, the sine of 60, the cosine of 30, the tan of 30, the tan of 60, and then we'll do some 45s. Okay, so sine of 30 right now, if you're standing at 30, sine would be what over what?
1/2.
1/2, 1/2. That is the exact trig value of sine 30. If you were to punch sine 30 right now in your calculator would say 1/2, 0.5. Okay? Cosine at 60. So here's 60 degrees. You're standing at 60 degrees. What would be the adjacent over the hypotenuse? Also 1/2. What's the sine at 60?
Root 3/2.
Good job. What's the cosine at 30? Root 3/2. Let's do some tan. What's the tan of 30? What is the opposite over the adjacent? Root 3/3, right? You would rationalize it to be root 3/3. What's the tan of 60? Opposite over adjacent, so just root 3. Now let's do sine. What's the sine of 45? What's the opposite over the hypotenuse? It'd be 1/√2, or another way to write that rationalized would be root 2/2. Cosine at 45 would also be 1/√2, which is root 2/2. The tan, however, the opposite over the adjacent, again, it doesn't matter what 45 you're standing at. The opposite over the adjacent is 1. This is how I do what we're about to do. At the top of my paper, I'll draw 2 right triangles, and then whenever it asks me for sine or cosine, that's what I use. This is right here what I use. However, Miss Davis, and there's other, you can like YouTube it if you want to, there's other ways to solve these ones right here, these special ones, these acute ones, more particularly these reference ones, okay? If you remember last year, she made a chart like this: sine, cosine, tan. Do you remember doing one like this? Maybe? In this first column, you would have 0 degrees, 30 degrees, 45, 60, and 90 degrees. I'll write the radians in a moment because you should know the radians also. And then the trick to this part is doing the following. You start it here and you go 0, 1, 2, 3, 4. And the middle, you go backwards. 4, 3, 2, 1, 0. Put everything over 2, 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 and over 2. And then square root the top numbers only. Square root, square root, square root, square root, square root, square root, all the way. Now, some of these actually simplify to something that you should write instead. For example, what's the square root of 0 over 2? What does that actually make? What's the square root of 0? 0 divided by anything is still 0, so you can ignore that. Even this one, square root of 1 is what? 1, so this is really 1/2. And then this one over here, what's the square root of 4?
2.
What's 2 divided by 2? So you can ignore that. So those you could rename 0, 1/2, 1. To fill out this bottom right here, to fill out tan, you have to know an identity that we're going to be more familiar with as it goes on. You can write this down. The tan of theta is equal to sine of theta over cosine. Your sine divided by your cosine. So your top number divided by your bottom. So 0 divided by 1 is 0. 1/2 divided by square root of 3 over 2 would be 1 over square root of 3, or would rationalize to be square root of 3 over 3. Square root of 2 over 2 divided by itself is 1. This one would be root 3. This one, 1 divided by 0, is actually undefined. It doesn't exist. Okay? So why is this chart good? Like I said, there's a million ways to do what we're about to do today. Like I've even seen they do these hand tricks on YouTube. But what I'm saying to you is if I said to you, hey, what's the cosine of 45? You could go into this chart, cosine 45. Oh, it's root 2 over 2, Mrs. Setta. Good. All right, what's the sine of 60? Sine 60, root 3 over 2. So you either have to do it this way and memorize that, or you'd have to draw right triangles and know that. Are you with me so far? Does that make sense? All right. By the way, above 30, I want you to put the radian form, which is pi over 6. 45 is pi over 4. The way I know that is because of 4, and it starts with a 4. And then the 3 and the 6's go together, so pi over 3. 90 is pi over 2. So we are now going to learn to find exact trig values for these, but for bigger ones, for like 225, 330, 315, okay? Negative 900, something like that. You got this handy now? All right, so let's to the side. Find exact values, no calculator. And I'll write a few here. Sine 225, tan of negative 150, cosine of negative 240, tan of 315. I'll put these other ones down here. You can copy them when we get to them. We'll just start with the degrees and then we'll work our way through radians. Let me clarify something before we begin, because this is what a lot of students don't understand. If this angle is negative, does that mean your answer is going to be negative? No. Do not assume that this is negative, your answer will be negative, okay? So that's the first thing. I don't want us to ever think, oh, it's negative, negative. No, no, no. Negative 150 just means, oh, I go this way. I go counterclockwise. That's all that it means. All right, so number one, I want you to find a reference angle. What's a reference angle? A reference angle, if you remember, this is from, you guys did this a while ago. Reference angle is a small acute angle between 0 and 90. It's the one that makes it closer to 180 or the one that makes it closer to 360. And then we need to know what quadrant it's in, because we're going to draw it in that quadrant. So sine of 225 without our calculator. What's the reference angle to 225? Anybody know?
180.
Is it closer to 180 or is it closer to 360? How much by? 45. The reference angle is 45. So you are going to go to that little chart you made, or the triangles, and you're going to find out what sine of 45 is. What's the sine at 45? What does it say? Root 2 over 2. So my answer is root 2 over 2. However, it might be a negative or a positive depending on what quadrant I'm in. Well, how do I know what quadrant it is? Well, go back to the original, draw it for me. 225 is here. What's that little famous phrase we use to know our signs? All, not a set of Sharon. All students take calculus. If I land in this quadrant, the only thing that's allowed to be positive is tan. This is sine. So should it be positive or negative? There's your answer. Done. That seemed long, but I promise you, you'll get faster as we do this more and more. So let's do it again, okay? Negative 150. Are you closer to 180 or are you closer to 360, and by how much? 180 by how much? 30. So we are going to go to the tan of 30. So again, look at your chart. Tan of 30. Oh, I know what it is. It's root 3 over 3. So write down root 3 over 3. But is it positive or is it negative? Well, that's because you got to know what quadrant you're in. So if here's 0, here's negative 180, wouldn't you agree negative 150 would be here in that third quadrant? All students take. Oh, what's positive there? And that's what I have. So it's positive. You don't have to write the positive, but I am writing the positive. Let's do it again. Negative 240. What's the reference angle? You closer to 180, you closer to 360, and by how much?
180.
By how much? 60 degrees. So you are going to go find cosine 60 for me. Somebody tell me what cosine of 60 is. 1/2. Your answer is going to have a 1/2 in it. You have to decide if it's positive or negative. This is how you decide. You go to the original, you draw it. Here's negative, here's 0, here's negative 90, here's negative 180, here's negative 270. So wouldn't negative 240 be between them? All students take. Is this answer going to be positive or negative? Negative, because only sine is positive there. All right, you try to do tan 315 right now. What's the reference angle?
360.
No, that 360 is not the reference angle. 45 is the reference angle. Okay. Tell me what the tan of 45 is. Then tell me what quadrant 315 is in. So tan 45 on my chart. Tan 45, 1. Is it positive or negative? Well, let's find out. 315 is in here. All students take calculus. Only cosine is positive, so that means that's negative. Done. All right, let's move on now to the radians one. Do you have these written down? These are our last two, and then we're done. Okay? Sine of 4 pi over 3, and then cosecant of 7 pi over 4. And then we're done. This is all you're doing today. What is the reference angle? We learned a trick when we had the pi's over 3s and the 4 pi over 3. What would be the reference angle when it was all that? What was the reference angle? Do you remember? It was just what? Pi over 3. So go on your chart right now and find for me what the sine of pi over 3 is. Sine at 60 is root 3 over 2. right? Root 3 over 2. But here's your problem. You need to know where 4 pi over 3 exists. So here's how I do it. I call this 0. I call this pi. If this is 1 pi and I have a denominator of 3, then I'm going to call it 3 pi over 3. Do you agree to that? If I double it, I get 6 pi over 3, which is 2 pi. So where would 4 pi over 3 be? Would it be after the 3 or before the 6 there? What do you think? In quadrant 3 or in quadrant 4? Right, 4 pi over 3 would be right there. All students take. Is the sign going to be positive or negative then? Negative. All right, we'll do it again. Cosecant. What is the reciprocal to this one, by the way? If it's 7 pi over 4, what's the reciprocal? I'm sorry, reciprocal. My bad. I'm giving away. What's the reference angle? Pi over 4. The reciprocal to cosecant is sine. So when I do this one, I actually find the sine of pi over 4. What is the sine of pi over 4? Root 2 over 2. I don't want root 2 over 2. I want its reciprocal. I want the reciprocal because I want cosecant. What it would be the reciprocal of this guy then? Just flip it. 2 over root 2. But then rationalize that for me. What would be the final answer then? Just root 2. The answer is going to be root 2, but you have to know what quadrant it's in. So one more time again, let me show you how to do this. If over on this side is 0, my denominator is 4. Over on this side would be 4 pi over 4. It's got to make 1. Back over here would be 8 pi over 4. Would 7 pi go in quadrant 3 or go in quadrant 4? All students take calculus. Does that C stand for CSC? No, that's for cosine. So is this positive or negative? Negative. Okay, now your turn. You have a 13.3 worksheet, I believe. You should. Take it out. You should have it. You guys are sleepy. I turned the lights off and you're going to bed. You have that 13.3 worksheet?
Yes.
Yes. Okay. You need to do, cross off 10 and 14 for me, because we're going to learn how to do those tomorrow. You need to do 8 through 15 right now. Bring it up to me, and then I will give you your second homework sheet, and then you're done. That's all you have to do. Okay? That's it.